Understanding the properties of ice has become more and more important in this time of climate uncertainty. My name is Stephanie McClellan, and I'm a student at Imperial College London. In my undergraduate degree, I had the privilege of working as a research assistant in Antarctica. The aim of our research was to try and understand how ocean currents interact with the continental ice shelf. I was there for 2 months and fell in love with the continent and its rare landscape. Ice, in its various forms, has hidden complexities and characteristics that have shaped the Earth and its ecology through time. I'm hoping to learn more about ice and the current research being conducted at one of the top universities.
I'm here at University College London to learn more about the dynamics of ice. We'll be getting a tour by PhD student Alexandra Seymour Pierce. I'm here with Alexandra, and she's going to give us a tour of the ice physics lab at UCL and teach me more about high-speed friction. So to what I understand, you study high-speed friction on ice. Would you be able to explain your research a little bit?
Yeah, so what I have in the cold room is a high-speed turbometer, and this is a device that studies wear and deformation slurs and measures the friction of any material sliding on another material. And so we have one in the cold room, so we can layer up with ice, and you can then study the effect of the surface of the ice and the impurities in the water on the friction of any slider that you choose to put on it.
Would you be able to show us how the instrument works?
Yeah.
Great. Thank you. Would you be able to explain what you're about to do?
Yeah, so this is a square slider, and it allows us to look at the difference of geometry on the friction. So we have round and square sliders, and then we position it on a load cell here. And it's curved because then we can avoid ploughing of the ice, and that produces a lot of fracture. So I'm just going to set it all up and turn it on. I'll show you some preparation.
The lab consists of a 5-chamber complex of interconnected cold rooms controlled at various temperatures below zero. Research conducted in the large cold rooms contributes to the laboratory's mission to understand the evolution and dynamics of the Earth's ice sheets. This is accomplished through theoretical modeling and laboratory experiments on the mechanical and physical properties of ice. One thing I just couldn't adjust to, though, was how chilly it was in there.
So how cold do you keep each room?
It depends on the work that you've done. This room can vary down to -30, which is currently at -3, so it's not that cold. If you're doing planetary science applications, you tend to do a lot colder, like -20 as a standard. Some rooms are at -5, so it just kind of depends on who's using it at what time and what is being stored in there.
Well, thanks so much for giving me a tour. So one final question, what's after this research? Where will it lead?
So once you know the influence of all the different factors, speed, temperature, geometry, you can start using results for science-specific stuff and really just kind of minimizing the friction as you go.
Great. Well, thank you so much. It was great to meet you. Thank you.